Okay, let's record it down so that you can review it yourself. Let's try the. It's usually about 30 there lah. Electric.
Teacher, can you go to question 12?
You want to meet me to discuss question 12?
Yeah. I forgot
Okay.
what's the couple already.
Say a bit louder.
I forgot what is talk of a couple.
Oh, okay. A couple is just two forces equal opposite direction, that's all. Consists of two forces, each of magnitude F, and act in opposite direction in the same plane. The perpendicular distance between the two D. What is the torque of the couple? Torque is just moment of a couple lah. That's all. Right? So it's just one force times the perpendicular distance. FD. Answer C.
Oh.
Okay, next question.
Yeah, that's it. Can go to DC circuit already.
Okay.
Teacher, it's not so talk of a couple is same as talk basically. Same as the moment no, yeah.
It's only used for couple. The torque of a couple is basically moment of a couple, that's all.
Okay.
Okay, let's go. How about this one? Number 30. A fine mist of oil drop is sprayed into air. As the oil drop leaves the nozzle of the spraying device, they can become electrically charged. What is not the possible value of the charge in an oil drop? Yep. What's the answer?
Not possible. Zero.
It can be zero. No charge. It must be multiple of 1.6 times 10 to the power minus 19.
Oh
B.
yeah. What
Cannot
is
be B. The charge are
cannot be B.
quantized. There's integral multiple of E. E is 1.6 and 10 to the power minus 19 Coulomb. Okay, in the circuit shown, a fixed resistor X is connected in series with a battery and variable resistor. The power dissipated in resistor X 7.2 here when the current 3 ampere pass through it. The variable resistor is adjusted so that the power dissipated in X is increased by 50%. What is the new current in the circuit? Okay, what is your answer? Ken,
Uh
what will this one first? What will this one first? Get the formula and use the formula to calculate the new current. You have given current, power, resistance. So it's I square R. So your X is that's your power, that's your I square. Right? Using this equation. Let's say we replace the R with the X, 0.8 ohm. Current is power divided by resistance. So now we change the power, right? 1.5 times, 150% increase by 150%, so it's 1.5 lah. And 7.2, right? It's 7.2. And R is 0.8. R hasn't changed, right? The resistance of X hasn't changed. It's always the same. It's only that we change that. We change the current, that's all. Can.
Yep.
Okay, what's your answer for this one? Potential difference across the metal wire is kept constant. The length and diameter of the wire are both varied. The type of metal is kept the same. How is current in the wire related to I and D? Get the equation. It has to do with resistivity. So resistance formula, resistivity formula.
Yeah.
What's the answer?
For current is directly proportional. Okay.
Right? Resistivity formula. We want length and diameter. Length is L. A is by D square over 4. So 4 go to the top there. Then V equals IR. Replace our R. Okay. We are told that potential difference across the metal wire is kept constant. V is kept constant. So R is kept on there. Right? There's a new formula. So take all we want I. So subject I. I. And take this across there. D square. This L. So that's your answer. Donkey. Can. Which is not clear. Resistivity always will come out one. The formula. Yep. What is the problem? Anything not clear?
Okay.
Okay. A student sets up a circuit. The circuit diagram shows how the positive and negative terminal of the voltmeter are connected to the circuit. The voltmeter has initial reading that is positive. Which changes, if any, in temperature, light intensity would cause the voltmeter reading to decrease?
I think it's A.
Let's see. Temperature increase, this one will reduce. Right? Initially, I told you it's positive. Uh, light intensity increase. This one will be smaller. The potential difference across here will increase. Okay, good. A. Any comment?
No.
Okay, let's carry on then. Some resistors and a battery of electromotive force E and negligible internal resistance are connected in series as shown. Which statement is correct? Yep. What is your answer?
should be donkey.
The sum of potential difference across the resistor equal, okay? Yep, donkey correct. Kirchhoff's second law. This one memory work only lah, nothing much lah. Very repetitive, very common. Kirchhoff's first law is a consequence of conservation of which physical quantity. Yep,
Ch- charge. Second only energy.
charge going in equals charge going out. Oh. Total charge going in equals charge going out at a junction. Okay, this one is a bit more challenging. Diagram shows a network of resistors. Each resistor has a resistance of 16 ohm. What is the total resistance of network between X and Y? I remember if it's parallel, you divide by N. If it's 6, 3 in parallel, divide by 3, it get 2 ohm. Replace each of them by a single resistor. Yep. What is your answer?
First one, I 6 divide 3, is it?
This one,
6.
6 divided by 3. This one, 6 divided by 6. 6 divided by 3. Then replace it. Lor. Replace with 1. Replace with 1. Replace with
Oh,
1. Then add them out. Lor. Like that. Lor. 2 ohm.
yeah.
1 ohm. 2 ohm. So add them out. Lor. So replace the parallel resistance with its resultant resistors. Right? Combine resistance is just add them up. Lor. Can.
Okay. But does it work if the same resistance? I mean, different resistance on each.
Say again.
Does it the formula still same, right? If it's different resistance.
If it's different resistors, it's a bit more challenging. Now you have to use 1 over R. Lor.
Oh, okay,
Reciprocal.
okay.
Lor. Okay. If
Yeah.
it's in series, you add them out. Lor.
Hmm.
Okay. Any other comment?
No.
Yep. Any other comment?
No.
Be a bit louder. Can't hear.
Don't have.
Okay. In the circuit shown, a battery of negligible internal resistance, negligible internal resistance in series with a pair of resistors R1, R2. Circuit is to be used to test whether the electromotive force of a particular cell is 1.5 volt. Test whether this is 1.5 volt. The cell is connected between the terminal X and Y in parallel with R2 and in series with the galvanometer. One is in series with galvanometer. Which statement about the test is correct?
Boy?
Say again,
Is it boy?
battery does not need to have a EMF of 6 volt. It need to have a 6 volt, right? You need to have 6 volt so that the potential across there, potential difference across R2 is 1.5. So if this is 1.5, this is 1.5, there's no current here, right? You just check, PD across 20 ohm, right? It's 20, add these two together, times 6, it's 1.5, so this is 1.5 here, this 1.5 here, no current through here. Galvanometer no need to be calibrated. It doesn't have to have a scale. As long as it is working and the, the current, the needle, or the deflection is always the same, it stays the same, then yeah, we know it's zero already. Okay or not? Doesn't need a scale to show it's zero. As long as it's not deflected, then it is zero. Okay?
Yeah.
Ask whatever is not clear, ask. Okay,
But I don't understand, like sometimes I don't understand this type of the graph.
this type is potential divider. So you must remember the potential divider formula. No? If not, you can calculate the current through here first. Then calculate the PD across R2. Which you get 1.5 also. Right? If you don't want to memorize formula, basically it's this one over the whole thing is the voltage here over 6. This is the formula. What is not clear? You ask, I'll clarify to you for you so that you can solve this type of problem.
Yeah, can move on.
Say a bit louder.
Yeah.
Okay, okay. This one over already. Let's go to the next one. Okay, 2023, May, June 13 and 23. Paper 13 and 23. Roughly about 30 there. A metal wire is connected between terminal of a cell so that there is a current in the wire. Which statement is correct?
A.
A, no? Good. It's the electron that is moving. The atom or the ions doesn't move. The electron. Two resistors or resistance R and 2R are connected in parallel with a battery of EMF 12 volt and negligible internal resistance. Total power dissipated by the two resistors is 36 watt. What is R? Quite popular this type of question. Find the resultant resistance also. And find the power dissipated in the resultant resistance. No? Then can find your R. No? Yep. Got the answer?
Yeah, I'm working on it.
Can?
Oh yeah, got it.
Just use this
Got it.
formula. P is V square over R. Right? P is 36. That's 36 watt. And go with this R. Either you find the resultant resistance if you want to. If not, go step by step. No? Apply your V square R to this one and to this one. No? That one for here. This one for here. And then times 2R. And simplify it. Okay. A wire has a length of 3 meter and is made of metal of resistivity 4.9 times 10 to the power minus 7 ohm meter. The potential difference of 12 volt is applied across the wire so that it has a current of 1.4 ampere. What is the cross-sectional area of the wire?
Okay, yeah.
Yep. What's the answer? Ken?
I got B.
Okay, B, correct. Just replace your R with V over I. No? That's your V, that's your I. And resistivity there. Length is 3, then A. No? A cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. The thermistor is placed in a beaker of water, and the temperature of water is slowly increased. The graph of current against temperature of the thermistor is plotted. Which graph will show the variation of I with T?
Thermistor, I think is a
Remember,
boy, is it?
thermistor, as the temperature increases, the resistance decreases.
Is it boy?
Yeah, quite good. As temperature increases, the resistance of thermistor decreases. Total resistance of circuit decreases. So current increases. Current increases. This is more complicated lah. A battery with internal resistance is connected to a parallel arrangement of two resistors and a switch. As shown, initially the switch is open. What happened when the voltmeter and ammeter reading? What happened to the voltmeter and ammeter readings when the switch is closed?
Voltmeter decrease, ammeter increase.
Voltmeter decrease, ammeter increase. Okay, let's see what's happening. You close the switch, the combined resistance will be smaller. So total resistance in the circuit becomes smaller. So current increases. Correct? Remember, this voltmeter measures the terminal potential difference or potential difference across the two resistors. So basically, they are sharing. Right? This is constant EMF we share between this resistor and this resultant resistor. So if that resistor decrease, the voltmeter will decrease, correct? A. Okay, anything else to clarify?
No,
Okay. Kirchhoff's first law can see repeat. States that the sum of current entering a junction in a circuit is equal to the sum of current leaving it. The law is based on conservation of physical quantity. What is a physical quantity? You got 10 more minutes.
first law is about charge. A.
You know,
Wait,
memorize
yeah,
how this memory works. You must do very fast to save time. Two resistors have a combined resistance of 34 ohm. When connected in series, the same resistors have the combined resistance of 7.4 ohm. When connected in parallel, what is the resistance of one of the resistors? That one be R, one be S, the resistance. And work out through, work it through. And the resistance be R and S. R plus S is 34. If it's in parallel, you take reciprocal of them. This one over 7.4. And solve the equation. No? This is a math problem now. Right? Replace R with 34 minus S. No? Then multiply by S into 34 minus S. Can
Uh, okay.
any comment? It's a bit more complicated lah, but you need to this a lot of maths lah. It won't happen in
Yeah.
paper 2 lah, but paper 1 can lah, because you only need one mark only. Any comment or anything you want me to explain further?
No.
Okay, let's go to 37 then. Potentiometer circuit is used to investigate electromotive force of cell X. The cell X. The cell X. EMF of the cell X is known to be approximately 0.5. 0.5. The driver cell has a negligible internal resistance of 2 volts. Negligible internal resistance. EMF is 2 volts. The sliding contact is moved along a uniform wire, resistance wire between Q and R to a point P where the reading of galvanometer is 0. So at P, galvanometer reading is 0. What is the expression for the approximate length UP?
A.
Say again.
Is it A?
Let's see. QP over QR is X over 2. So QP is cross multiply. This one times 2 here, times 2 here, you get quarter. So A. Okay, good. Any comment?
Oh, no.
No. Okay. Students set up a circuit with a battery, an ammeter, a heater, and a light dependent resistor, all in series. The battery has negligible internal resistance. The voltmeter is across in parallel with the heater. On figure 5.1, complete the circuit diagram of this arrangement. Can give you a chance to look at it first, to work it out first before I give you the answer.
Okay.
Okay,
Teacher, but like, how do you know how to arrange one?
you are told that the student set up the circuit, a battery, yes, your battery is given, ammeter, ammeter can be here anywhere in the circuit, doesn't matter. Heater, light dependent resistor, they are all in series. They are all in series.
Only voltmeter.
Voltmeter is across in parallel with the heater. Voltmeter is always across the heater. Yep.
Ah, okay.
All this you must know.
Yeah. Teacher, but I noticed most of the scenarios, the voltmeter always parallel one.
Voltmeter is always parallel, not in series.
Parallel.
Ammeter is inside the circuit in series one. That you must know.
Parallel to?
Parallel because you want to measure the potential across the heater. Whereas
Oh,
ammeter,
alright.
you want to measure the current inside this circuit.
If it's parallel to the battery, means you want to measure the EMF, right?
If there is no negligible internal resistance, no? If you put across the battery, then you measure the EMF, no?
Oh, alright, alright. I get it already.
Whereas if it is if the across the battery with internal resistance, then you measure terminal potential difference, no? Anything else you want to ask or clarify?
No.
Okay. How do they mark? Correct symbol for heater or for LDR, either this one or this one correct, 1 mark. All correct symbol in series and no extra symbol, right? All these symbol correct, no extra symbol, another mark. Correct symbol for voltmeter and in parallel, this one in parallel, voltmeter, another mark, lor. That's how you get a 3 mark. Lor. Heater is wire made of resistance 1.5, 1.1 times 10 to the power minus 6 ohm meter. The wire has a length of 2 meter and cross-sectional area 3.8 times 10 to the power minus 7 meter square. The reading on the voltmeter is 4.8. What is the resistance of the heater? Anytime it will be cut off now. Right? Always resistivity formula.
Five.
Can you calculate out of
Five
reading ammeter?
V equals IR. So, I 1.8 over 8.
Can or
Yeah,
not?
yeah, can.
Any comment or anything clarify?